So today our learning intention is to learn about the graphs of the reciprocal circular functions. So can you remind us about what are the reciprocal circular functions?
Yes. Sec equals 1.
So we have
on cos.
second x, which is equal 1 on cos x.
Cosecant.
Cosecant x
1 on sine.
is 1 on sine, and one more.
Cot.
Yes, cotangent,
1 on tan.
which is 1 on tan x.
Or cos on sine.
So there are three circular functions, so three reciprocal. And let's sketch the graph of the second x. How we were sketching the graphs of the reciprocal functions? What we were starting from?
Do the normal.
We sketch the original function. So let's start from sketching cos x. Pi on 2, pi, three pi on 2, and 2 pi, negative pi on 2, negative pi, 1, negative 1. So we all know well that graph of the cosine function. So that is the cos x. Now when we do 1 over, when the original function equals 0, what we will have for reciprocal function? We'll have vertical asymptote, because we cannot divide by 0. So we'll have asymptotes. X equals negative pi on 2, x equals pi on 2, and x equals 3 pi on 2. So we have the asymptotes repeating themselves every pi. Negative pi on 2 plus pi on 2 plus pi 3 pi on 2. Now, where the original function has maximum, what the reciprocal will have? Minimum. It will have minimum. When this has maximum, this will be minimum, because when we divide by the biggest number, we get smallest number. And here, when it's approaching 0, reciprocal will be approaching infinity. So that will be the graph. Here, we have like this, and so here we will have like this. So this is the graph of the second x, 1 on cos x, which we built just purely using the idea of sketching graphs of the reciprocal function. Make sense?
Right, because they're all like the minimum is 1 and negative 1. Are there like turning points always at the same point?
No, because it's 1.
Yeah.
1 over 1 is 1.
Also for sine.
And for sine will be the same,
Yeah.
but where we have maximum of sine, we will have minimum of the 1 on sine. And vice versa. Yes?
Don't you need to on the 2 pi?
Add bit here, yes. We add bit here. Like this. So, sine x we can sketch in exactly the same way. How we can, in general, how we can obtain graph of the sine from the graph of the cosine? Yes, it's translation pi on 2 in positive direction. So if we translate this graph pi on 2 to the right, we will get the sine and cosecant x. Let's do cotangent x. Let's do cotangent x and then look into the sum example. So tangent have, so y equal 10x, yx. Where are the asymptotes of the 10? For which values of x we have vertical asymptotes for 10x? Pi on 2. Because when cos equals 0, then 10 not defined. So we have pi on 2, we have negative pi on 2, and that is the tangent graph. And then it's repeated every pi. If we do reciprocal graph, I'll probably sketch another one, pi on 2. So we have pi and 3 pi on 2. When tangent equals 0, cotangent is 1 on tangent. What will have at x equals 0? Asymptote. We'll have vertical asymptote. Now, when it's approaching infinity, what will be the value of cotangent? What will be the cotangent of pi on 2?
Becoming really small.
Large.
More exactly. What is cotangent? If 10, what is 10? Is sine over cos.
0.
Yes, it will be 0 because cotangent x will be cos x on sine x. So when cos x equals 0, cotangent x will be 0. So x will have it will be 0 here. And when it's very small, positive will be very big. So that, and another asymptote will be at pi. So that will be cotangent x. Here, again, it will be from 0 and going like this. So it's like 10 reflected in y-axis and then translated, or reflected in x-axis and translated by pi on 2. So that is the graph of the cotangent x. Make sense? Now let's do example from the booklet. Let's sketch. Open page 47. Open page 47. And we will do example 1a. So let's sketch the graph. Let's sketch the graph of y equal. Oh, let's do b. Let's do b. Y equal cosecant of 2x plus pi on 3. First, what we should do before starting sketching any graph?
Do the normal. Or change it to 1 on
Take out 2. We need to make coefficient of x 1 in the bracket. Never scale. I've told you many times. Never.
At the same time, 1 on sine, take out 2.
Yeah, let's first take to here. Make coefficient of x in the bracket 1. So cosecant of 2x plus pi on 6. Now we are ready to sketch it. And we can do it in 2 ways. We can either sketch graph of the sine and do reciprocal, or we already know how the graph of the cosecant looks like and transform it. So can be done either way, whatever you feel more comfortable with, what's easier for you, do this way. Which way you want to go? Sketch graph of the sine?
Can we please do both?
Yes, we can do both. So let's start from sketching graph of the sine. So, pi on 2, pi, 3 pi on 2, 2 pi, negative pi on 2, negative pi on 2, negative pi. So, first of all, if you're sketching y equal sine 2x plus pi on 6. What is the period? What will be the period of this?
Pi.
Period will be pi. It's because we have what kind of transformation is this?
Dilation by factor of 2 from the y-axis. Half.
Half. The relation by factor 1/2 from the y-axis.
So, but if you do mapping notation, it's 2x, then you take it back, it's x on 2.
Yeah, no, for this quite simple, you don't need even to go through all making notation. You can tell straight away that it is dilation by factor 1/2 from y-axis, and what is this?
Left.
Translation pi on 6 to the left. Pi on 6 to the left. So we will have 0 translated, so we will have pi on negative pi on 6, negative pi on 6, that's where will be 0. Now, what will be the y-intercept? What will be the y-intercept? When x equals 0, we have 2 times pi on 6, pi on 3, sine pi on 3, root 3 on 2. Which is approximately 0.85, so somewhere here. And where will be maximum? For what value of x will be maximum?
1. Oh.
No, not y will be equal 1. For which value of x will we have maximum? Where is the maximum? Pi on 2 minus pi on 6. Where is the maximum of sine? At x equals pi on 2, right?
And negative pi on 6. It will be
Negative pi on 6 is 0.
Oh, it's sine.
When it's sine, it's sine. When x equals negative pi on 6, we get 0. Sine 0 equals 0. That's minus pi on 6, it's a x-intercept. Maximum of sine is when x equals pi on 2, right?
How did you
So pi on,
So how did you figure that out?
what?
The maximum.
Sine, okay. This is called sine graph.
Oh, pi
And
on
this is
2.
pi on 2.
With the transformation.
Now, when we move the pi on 6 to the left, what will be, where will be maximum? We were at pi on 2, now we move pi on 6 to the left. What will be the way? Pi on 2 minus
Pi on
pi on
3.
6.
Pi on 3.
Will be pi on 3.
But which we
Oh, yeah.
dilated it, right? We dilated it.
Will be pi on, no, because we delayed it, so it's not from pi on 2, it will becomes at pi on 4, because we have these 2. And then pi on 4 minus pi on 6 is, what is pi on 4 minus pi on 6?
How did you go to pi on 4? It's times 2. Pi on 6 times 5.
It's dilation from y by factor 1/2. It comes twice closer to y-axis. When we have coefficient 2 here, it comes twice closer to 1. So pi on 2 becomes pi on 4. The dilation by factor 1/2. Now, pi on 4 minus pi on 6, pi on 12. So you'll have maximum at pi on 12. So that is First bit. Now, next 0 period, you say it is pi. And next 0 will be minus pi on 6 plus pi will be 5 pi on 6. No. No, we had 0 at minus pi on 6. Where will be next 0?
It says in the question from negative pi to pi.
Negative pi to pi, okay.
That's what the question says.
Yeah.
I'm happy to do it.
Yeah, we haven't get to pi yet. We haven't get to pi yet. What will be if we had? Okay, let's solve.
What is it?
Let's solve 2 times x plus pi on 6 equal. We solving what will be the x-intercept. Where sign has intercept? Normal sign.
Pi on 2. Pi.
Pi everywhere. So pi equal pi n. Equal pi n. So x plus pi on 6 will be equal pi n on 2. So x equal pi negative pi on 6. Negative pi on 6 plus pi n.
It gave us an interval negative pi to pi.
Yeah, we will stop.
That's not
When we get to pi, we will stop. So what will be the next? We have at negative pi on 6. Where will be next x-intercept? Pi on 6 minus pi on 6 plus pi on 2. Pi on 2 plus
Pi on 3.
pi on 3. So we have pi on 3 that will be mean. Pi on 3. Now, then we will have, where we will have another negative. Where we will have negative minimum.
Plus another pi on 2.
Plus another pi on 2. No,
7
that will be
pi.
0.
Well, that's 7 pi on 12. The other 0. And then just do in the middle of them both.
Yeah, so next 0 will be
8 pi on 12.
will be pi on 3 plus pi on
2 pi
2.
on 3.
We have pi on 3 plus pi another pi on 2.
Or 7 pi on 12.
Pi on 3 plus pi on 2.
Is
Come on, what's wrong with you after? Yes. 5 pi on 6. Yes. 5 pi on 6. And we should stop at pi. When x equals pi, what will be sign equal?
3 on 6.
7 pi on 3. What is there?
Wait.
When x equals pi, x equals pi. X equals pi. So we get sine of 2 times 7 pi on 6, which is 7 sine 7 pi on 3.
Root 3 on 2.
7 pi on 3 is root 3 on 2.
Then how do we get that?
So this is pi root 3 on 2. And we continue here to negative pi.
Yeah.
This was negative pi on 6 minus pi on 2 will be 2 pi on 3. Next will be negative 2 pi on 3. And again, it will go to, when we put negative pi, if we put negative pi, we have negative 5 pi on 3. Negative 5 pi
Well,
on
we just know the period, so what do we
yes, or using period, so that will be again negative pi root 3 on 2. Now let's sketch reciprocal.
Yeah, Mr. I'm not happy. The graph is hairy. That's like minus 5.
What? Really graph is hairy.
Now skip, let's sketch reciprocal. Let's start, what we should start from? Asymptotes. Yes, we sketch asymptotes. 1, 2, 3, we have 4 asymptotes. We have 4 asymptotes. What will be the equations of those asymptotes? This is minus pi on 6. This is, we have found pi on 3. Pi on 3, and this one was, what was this? Minus pi on 6 plus 5 pi on 6. 5 pi on 6. And this last asymptote was the equation minus pi on 6 minus pi negative 2 pi on 3, yes. And so when we have the minimum here, what we'll have for the reciprocal graph? Maximum. Now,
Wait, I have a question, Mr. B.
yes,
How can it be like, what's, oh, never mind, sorry.
okay. Now, what will be here? When we have this, when we have reciprocal, what this point will be equal? It was root 3 on 2, now
2
it
over
is
3.
2 over root 3, which will be a bit more than 1. So that is going like this, and here going like this. It was reciprocal, so this is negative pi 2 over root 3. This is pi 2 over root 3.
Like, Mr. B.
Yes.
So I was going to ask before, but I don't, like, so the maximum is at pi on 12, right?
This was at pi on
So
12.
then you would, on the left-hand side of the negative, you would have reached the maximum and then gone to negative pi. Like on the left, on the negative.
Sorry, here,
No, not of the inverse.
here,
Not of the inverse, just the normal one.
normal one, yeah.
On the left.
No, this pi, this,
No, on the left, like of the negative,
yeah.
like negative pi on 2 or 3 after the maximum.
This is maximum, not at negative pi on 2.
No, I know, but the maximum is after and then it goes down. It's fine.
No, maximum of these will
Yeah.
be to the.
No, it won't. Because the period is pi and you have the
We
maximum.
have from pi on 2 here.
No, pi on 2.
Then we do a period of pi negative pi. Yes, it should.
But it's fine.
It should be here. It's not up to scale. It's not like.
No, like as in negative pi over 3 is like after the maximum.
Negative pi on 2 root 3.
No, just negative pi is after the maximum.
Negative pi is after the maximum.
Yeah.
So
this pi on 12
I missed one term.
Yeah.
Yeah, I made it too wide here. Yes, thank you. Because next 0 we have minus pi on 6. No, minus 2 next is minus pi on 6 minus pi on negative 2 pi on 3. This is negative 2 pi on 3. And minimum will be next. This minimum is at 2 pi. This minimum was at 2 pi on 3. No, what was the minimum here?
Yeah, 2 pi on 3, so then it's negative pi on 3.
No, it's not 2 pi.
I think
2 pi on 3?
Oh, it's 5 pounds.
No, 5 pi on 6 is 0. 2 pi on 3. Let's do it properly. Let's calculate when sine
Oh, I think
equal when it will
it's
be.
7 pound 12.
Wait, Mr. Lee, what did we do wrong?
Huh?
No, like there's a before it gets to negative pi, like there's a maximum.
So okay, let's write down. Let's do calculation. All calculations before putting points. So yes. So we have first we find in this the x-intercepts, we have found that 2 times x plus pi on 6 equal pi n. So we've got negative x-intercept equal negative pi on 6 plus pi n on 2, which makes on the our interval negative pi on 6 minus pi on 2 negative pi on 6 minus pi on 2. We have negative 2 pi on 3, negative 2 pi on 3, negative pi on 6, negative pi on 6 plus pi on 2 will be negative pi on 6 plus pi on 2, pi on 2, 3 minus 2 pi on 6, so pi on 3. Next will be, next 0 will be minus pi on 6 plus pi will be 5 pi on 6. So those are x-intercept. Let's find maximums. When sine has maximum, when it is pi on 2 plus 2 pi n. So we have 2 times x plus pi on 6 equal pi on 2 plus 2 pi n. That is when sine equal 1. So solving this, we get x plus pi on 6
But it's going to be more than 1.
equal pi on 4 plus pi n. So x equal pi on 4 minus pi on 6. Again, 1/4 minus 1/6. We get 3 minus 1, 12. So equal pi on 12. X equals pi on 12 plus pi n. So what will be the solutions? What will be the solutions of the given interval?
Negative 11, pi on 12, and pi on 12.
So we have pi on 12. And we have negative 11 on pi on 12. Negative 11 pi on 12 and pi on 12. So we have two maximums. Now let's find minimums. When we have it's negative 1, we have 2x plus pi on 6 equals negative pi on 2 plus 2 pi n. We have x plus pi on 6 equal negative pi on 4 plus pi n. So x equal minus pi on 4 plus pi on 6. We have 3, 12 over 5, 12, negative 5 pi on 12 plus pi n. So we have negative 5 pi on 12 and another plus pi 7 pi on 12. So that's what we should do at the beginning to find all those points. Then we can sketch graph properly.
So then you don't even need to sketch the normal one.
Yes.
So you can just use all this information.
Yes, we can now sketch. We can use the information that we obtained.
How would you do it?
So we have zeros at negative 2 pi on 3, negative pi on 6, we have pi on 3, pi on 3, and we have another 0 at 5 pi on 6, and we have when it equals 1 and negative 1, it's equal 1 at negative 11 pi on 12, which is somewhere here, negative 11 pi on 12, and that's when we have minimum, when we have maximum, and equals 1. Then we have this, we have 0. Now minus 1 we have at negative 5 pi on 12. Negative 5 pi on 12. Then this, then we have x-intercept, we have found was root 3 on 2. y-intercept root 3 on 2. Then maximum, again we have 1 at pi on 12. Pi on 12, then we have at pi on 3, we have 0. We have negative 1 at 7 pi on 12. We have 0. Minus 1, we have at negative 7 pi on 12. And then at pi, we have 2, we have root 3 on 2. Pi root 3 on 2. And here we get, again, this will be the proper sine graph, which follows all. And now we can do reciprocal. We sketch the asymptotes, 3 asymptotes. And then we have, that will be and so we will sketch this node here. And this will be going like this. And here we have it going like this. So this will be the proper graph of the reciprocal graph. Yes? So it's good to find those points straight away. Find the coordinates of 0, x-intercepts, and maximums and minimums. Then we can do it properly. So that's how we sketch the...
Is this how you would sketch it? Like, it's the quickest way?
I will say we can sketch the normal reciprocal graph.
Just try
and then do transformation. Compress it twice and move pi on 6 to the left.
Yes.
I will say probably this will be easier for you guys. Okay, that's all new stuff for today. Like, subscribe, and donate to help fight terrorist countries and organizations like Russia, Iran, etc. Support Ukraine and Israel.